I've now set the trolley up with the ticket timer, the power pack, everything all ready to run. I've already tested it, so I've seen the little dots on here and they're coming out quite very well. So now I've set up this. I set up the collision trolley. This is one of the larger collision trolleys. You can have the small plastic ones. It really doesn't matter which. They both roll very smoothly. But you need to sticky tape the ticket timer tape onto there, and when you've done that, it's all ready to rock and roll. So let's have a go. Now I've got to hold that there. Strictly speaking, it's better to have one or two assistants, someone to turn it on, someone to catch it, but I've set this up so hopefully we don't need that. So here I go. Start it, let her rock and roll, and stop. That run is now finished. It's a beautiful little run. You can see the dots very clearly and all the way up to here, and that's plenty to be done for a good reading. We're now going to do some measurements on this, on the tape, and just realizing the first bits you get are always all scrambled because that's where the thing is hardly moving. So what we do is we now rule off every fifth line so that we get 5 spaces. So that's 1 space, 2 space, 3 space, 4 space, 5 space, and we rule there. So it's 1, 2, 3, 4, 5 lines. So 1, 2, 3, 4, 5. There's 1 space, 2 space, 3 space, 4 space, 5 space. And we just keep doing this until such time as we run out of lines to do. It does not matter if you don't start at the beginning, because what we're actually trying to measure is acceleration in the long run, and it doesn't matter where you start to get the acceleration. It's the difference in velocity divided by time that we're after. 1, 2, 3, 4, 5. There are several ways to do this analysis now. Some people like to lay it out in the meter rule and actually take the entire calculations, the entire displacements as they go. I much prefer to measure the increments as we go, right, and which is much easier in the long run because that's what you're actually going to record. However, we can do it both ways. It really doesn't matter. Some people like to cut them up and make a little histogram of them. But in actual fact, this is continuous data, and it's a bit wrong to make a histogram. A histogram can be used for continuous data, but it's generally when it's continuous discrete data rather than just continuous data that is not discrete little bits, and which this is just a continuous curve. So what I'm going to do now is just to measure every single gap. Now I've managed to get quite a few in, so we'll get quite a fair bit of data. Notice I made a mistake here. I did that on purpose, but just to show you, because I only did 1, 2, 3 dots in between there, and so you just make sure it's very clearly marked. And then what you do is you go through and you literally write on the tape the actual individual gaps that you've got. So this is 134 millimeters. I'll do this all the way to the end. And now I've got all the individual increments marked in here. There's plenty of them. 1, 2, 3, 4, 5, 6, 7 really good measurements, and that's heaps. We don't have to worry anything about the beginning, and we certainly don't have to worry anything about the end. All of these give us erroneous sort of readings. Now I'm going to put all of these readings here into a spreadsheet. These measures are consistent and it's very good that they are, but they are really, there's a lot of resistance involved in this exercise, far too much resistance to really give you a great result. That's because we're looking at a very low angle, you know, it's less than 10 degrees. So therefore the resistance of the tape, the resistance of everything you can think of about in there is going to cause this to happen. This is about 1/16 of the answer that I would actually expect if we had a really good set of laboratory conditions. Anyhow, the procedure is good, the results are consistent, and that's what really matters.